Section 3.4 in your book is all about counting principles, they say. You're going to use a lot of the same concepts from the fundamental counting principle, where if you have multiple events or multiple things to choose from, you multiply together. But there's an important distinction that we need to talk about, and that's the difference between a permutation. Oh, I left my R off in my word here. A permutation and a combination. So, what this section is about is how many different ways you can choose a group of people, or how many ways you can arrange or create seating charts or batting orders, things like that. And then we'll move from that into what's the probability of different arrangements. But we need to talk about the distinction between these two. And there's only one distinction, and it's very easy. In a permutation, order matters. So in a seating chart, the order matters. Who you put in seat 1 and seat 2, if you rearrange those kids, it's a different seating chart. It's a different arrangement. Or if any of you have planned a wedding, God knows if you put Uncle Mary next to Cousin John, it's not going to be a good outcome because they don't like each other. So order matters, and that makes it a permutation. A combination is when order does not matter. It's as basic as that. So examples might be, if you're just selecting a group of people to serve on a committee. Obviously, if it's just to sit there in a committee, nobody has a position, you're not doing a seating chart, you're not, nobody's like top person, second person, third person. You're just choosing a group of people. That would be an example of when it's a combination. So I have 3 situations that I have typed up here. They all start from the same premise. That would be if you had 12 students in a summer school stats class. How many different ways can you? And we have 3 different things that we're going to look at. Our first job is to identify, is that a permutation or a combination? And then I'm going to give you the formulas for each and how to complete this problem. So let's look at the first one. Choose how many ways can you choose 4 of them to serve on a summer student council? So there's no indication that they're going to be in positions or seated in a certain spot. It's just, I need 4 students out of this class who are going to serve with a group of other students. That would be a combination. A combination on that one. The order doesn't matter. You're just selecting 4 of them. All right, let's go to the next one. How many ways can you choose a first, second, and third place student based on their project grades? If you're having trouble deciding which is which, think about this, okay? If I'm going to hand out first, second, and third place, and I put Robert's name as the first place, right? And I select Mary, second place, and I select Brittany as third place. But then for some reason when I report it to who's giving out the prizes, I rearrange the order, and I mess up, and I put Brittany's name in this spot, and Robert's name in this spot, and Mary's name in this spot. That's a whole different situation. When you rearrange the name and it's a different situation, that makes it a permutation. So we're filling people into spots. This choice B would be a permutation. Permutation. Order does matter in that case. How about C, a seating chart? I alluded it in my description earlier. Order matters there. When you're making a seating chart, a batting order, you're placing books on a shelf, you're placing pictures on a wall, order matters. So that would be a permutation. Now let's talk about how to compute these things. Let's look at the formula for each. I'm going to shrink this just a little bit more so I can have some room but not lose what's up above. So there's the formula is this for a permutation. And it's going to look funky. And you might go, oh my gosh, that looks gross. It's not hard. So you have P stands for permutation there. You have N and R. N is familiar to you from chapter 2. N always stands for how many total people are in your sample or your group. And the formula is this, N factorial. If you've never worked with a factorial, that's just not me saying N with an exclamation. An exclamation mark is a math concept. It means take that number and multiply that number times each digit less than it all the way down to 1. So if I have 5 factorial, it would be 5 times 4 times 3 times 2 times 1. So that's factorial. And then over N minus R factorial. Let's talk about what that is. You know what N is. That's your total sample size. That's the total amount of students you're working with. R would be how many you're choosing. R would be how many you're choosing. N is your total survey size. So in in B, we identified that we had a permutation. And so we want to fill in this formula here. So my total number of students, N would be 12, because it says there's 12 students in a summer school stats class. That's how many total people I'm choosing from. So that would be 12 factorial in the numerator. 12 goes in that in spot too. R is how many I'm choosing. If I'm selecting first, second, and third place, I'm choosing 3 people to give awards to. So R would be 3. So it would be 12 factorial over 9 factorial. By the way, you can't cancel anything with the 12 and the 9 there. You would have to do 12 factorial on your calculator, hit enter, then divided by 9 factorial. In the next video, though, I'm going to show you a shortcut for doing this in your calculator, but I did want you to see that formula. You will see it again in Chapter 4 when we're talking about binomial distributions. Okay. So that's permutation. Actually, let's go ahead and do C, because that's a permutation also. I'm going to shrink this to make room again and scoot that up a little bit more. So on this one, in choice C, we identified that's a permutation. There's still 12 people that I'm choosing from. Only this time, if I'm making a seating chart, I'm using all 12 people. It's not like I'm only going to give 10 people specific places to sit and then the other 2 just float around. So you're using all 12. So it looks really weird. And you might, if you have been in enough math classes, you might go, wait a second, I can't divide by 0. However, 0 factorial by definition is 1. And it just has to do with this principle right here. So anytime you have 0 factorial, it just means you don't have any numbers here that you are multiplying by. So it's like dividing by 1. Okay, it just means you're not dividing out anything. So it's not the number 0. 0 factorial means there are no numbers that we're working with, so there's really nothing to divide by. So you would just do straight up 12 factorial, and that would be your answer there for how many different ways you can place people in a seating chart. So that was that was B is the top answer, and then we had C. So I just realized I never gave the answer to those. 12 factorial divided by 9 factorial, you end up with 1,320. So the first example, how many ways can you choose first, second, and third place? There's 1,320 different ways you could do that. It's kind of remarkable out of only 12 students, but that's what it is. 12 factorial, how many different unique seating charts you can make, because if you reverse places with 2 people, that's a different seating chart. Any of you that are educators, you know that's true. Sometimes it's just switching 1 or 2 students changes the whole class. 12 factorial gives you this ginormous number here, 479,001,600 ways you can arrange just those 12 students in a stat class. So that's those. Now we're going to go and pick up A. A is our only combination here. Oh, my borders got kind of funky here. Let me just, our permutation bled into our combination spot here. All right, let's do our combination formula. The formula is going to look very similar. Only it's C for combination, NCR. We're using the same letters we used before. It's still N factorial in the numerator. It's still N minus R factorial in the denominator, only we're going to divide out this R factorial. That's because we have to divide out all the different ways you arrange who we selected, because in combination it doesn't matter. So you're dividing out the extra combinations there. So let's fill in the numbers for this. So we still have 12 students in that class that we're choosing from. So N is 12. R, in this case, it says we're choosing 4 of them to serve on a summer student council. So R is 4. And we have to put that in 2 places in our formula. So that's going to give us 12 factorial over 8 factorial times 4 factorial. I've had students think that 8 factorial times 4 factorial is 32. factorial, but you can't do that mathematically. It doesn't fit in with what the factorial is. So let's say we didn't have a calculator, because your next video is going to show you how to do that on the calculator. But, anyway, so I'm going to write out just longwise, just so that you can see it at least one time. If we're doing this 12 factorial, oops, change colors, I didn't mean to. If we're doing this 12 factorial, 8 factorial, 4 factorial, here's what it would look like without a calculator, right? Here's 12 factorial. Yes, I'm going to write all of them out. 4, 3, 2, 1. Okay, that's in the numerator. Then we have 8, 7, 6, 5, 4, 3, 2, 1, all being multiplied together, times 4 times 3 times 2 times 1. So, in a fraction, anytime you have the same thing in the numerator and denominator, they'll cancel. So the 8, 7, 6, 5, 4, 3, 2, 1 will cancel with the 8, 7, 6, 5, 4, 3, 2, 1 on top. And then other things will cancel, like 4 times 3 is 12. That will cancel with that 12. This, I can go 2, cancels into that 10 and leaves me with 5. Everything in the denominator now has been canceled out. And all that I'm left with is 11 times 5 times 9. And I can multiply those three and get my answer, which gives me 495. So I'm squeezing it in here. I apologize for the messiness of it. Obviously, remember, you can kind of rewind the video as needed, but there are 495 ways that you can select 4 students out of a group of 12 to go serve on this committee. So that's the answer to part A. So that's what the formulas are. That's the difference between the two. Next video, let's look for the shortcut for how to do that on your calculators.